Now that I've given you a modicum of understanding, hopefully, about variables, and we can move on to using some, I reckon. Okay, so observe here we're in 16 color video mode 3, all right, 80 by 20 screen, and we're using the video mode OB8. Oh, okay, let's make a mental note of that. Now I'm going to open, let's go back to our lessons here and go to Pixel, and here we go. Set the video segment. We have a Mandela effect going on here. Apparently the words to the song actually are O-A-O. Oh, okay. What's with the discrepancy? Well, here we're in different video mode, 13H. Yeah, better known as 19. Yeah. So while we're here, okay, geez, what am I teaching you people? I don't really think we need to be initializing the data segment because we're starting in a boot sector here, and I can pretty much assume that we're coming into the world, a newborn baby, all initialized and all. So that is a pretty good start there. And don't really need a word. What's the word? Looking good. Here's what we'll do. Save this, I think here. Let's test our theory here. Copy that over to test AV and save that. Make sure everything's working. Yeah, pixel in the middle of the screen. Yeah, extraneous code. But I guess I've learned a bit more since then, so no needy here. So now that we got that, let me just save it, and I'm going to set this to read only there so we don't accidentally read over it, but we know we've already copied it over to test. We are good to work from there. Next, I want to try and declare a variable. Here we have positioned the pixel in the center of the screen using a bit of math. We know the values are the screen width times the up and down value. It's 200 pixels high, so halfway down, and then 160 pixels over, halfway across the 320 pixel screen. Great. So now I want to try and replace these values here with some variables. Right? Okay. So how about let's start here with this value here. So that would be my y. I'm going to just call this to make a long story shorter, my screen position, I guess, because, well, we'll see. Position, and that'll be a data word. It has to be a data word because the screen is wider than 256 pixels. If we used just a byte, it could have some wonky results. So let's put a value in there, 160. Okay, good to go. I should now be able to replace that, but this is a memory position, so I need to say, it's a place, a place in somewhere in memory, like that. Let me just see what happens. Error. No, you can't do that, I'm afraid. Can't really work with the variables in an equation like that. Let me strip this down first. So let me just move my screen position into DI. Okay, my screen position is 160, and somehow, so that should be middle of the screen. It's 320 wide. Somehow it ended up over here. Okay, why is that? Okay, but this is interesting. It's an incorrect offset. You could count the number of pixels and know what the value of the offset. But the reason the offset is incorrect, once you introduce variables, it is imperative that you define your origin. Let's go with OX7COO. Yeah. Let's try that again. So now this variable is in reference to something known. Okay. Let's see. Yeah. So I'm in the center of screen now. So using a variable. There, end of lesson. Now let's go a little deeper here. So now, well, the lessons, I'm going to do polar coordinates, I guess, now. Thing is, here, if I go, say, screen position, we know the screen is 320, right? So what happens if I go 322 here? Okay. Goes all the way to the end, overflows to the next line, and a couple extra pixels. Yes, okay, so this overflowing thing, if we're thinking in terms of staying in the boundaries and stuff, which hopefully we are, or even the ability to go outside the boundaries without overflowing. We want to think of this just a little bit differently, I think. What we want this to be our position Y, I guess. Yeah. Oops. What happened? Yeah, I'm sorry. Position Y. Like that, yeah. Copy. I'm gonna paste that in there. I'm gonna just set this back to 160. We should know that of course is gonna work. It's fixed. Yeah, normal, back to normal. And then let's do this a little bit differently here. Okay, I'll do that differently in a moment. For the time being, oh, I see what I did wrong here. This is I meant to say X here. Yeah, okay, that's why I was shortage of neurons firing for a moment there. Yeah, so that'll be our X, but we're not going to go outside the edge. Okay, now that I have that working, let me just comment that out. Okay, so here, let's say, what have I got? I'm just going to deal with this a little bit differently now. We're going to also define our Y position. X is good. We're happy with that. Our Y position. And I'll just say 100 halfway down the screen. Okay. And then here's the thing. We know we can't do an equation with that, right? So we have to use the multiplication, addition, and whatever features of assembly to accomplish that instead. So what I need to do first is get position Y into my accumulator, I guess, so I can start working with it. Into AX position Y, but of course it is a memory position. So in the brackets, good to go. There. Now, let's also, while we're at it, we'll just go ahead and make another variable for our screen width. Whoops. Like so, which is known to be 320. Again, I need to use a data word, or this will it will be insufficient. Okay, so now we have those two values. I can, let's see, okay, so I have AX loaded. All right, I need to multiply it. So into another adjacent register, we'll say, oops, BX, move BX. That's free, I'm not doing nothing with it. We'll put the screen width there. Right there, yeah, okay. So now we just need to do a little multiplication on it. That is simple enough. Mul BX. That will multiply BX with the value that's in AX and store it in AX. Yeah, simple enough. So now here, instead of loading the R value directly, we will load AX into DI. And let's see how many errors we get. Well, what do you know? It worked. This is our Y position, in case you're wondering. Where's the pixel? Well, it's over here on the left side of the screen. It's a little hard to see because there's other black and white text over here, but that's exactly right. We are, our Y is 100, halfway down the screen, and we have multiplied it times the screen width, and that's exactly where it should be. Okay, so now that we have that, we can reintroduce X. And then simply right here after the multiplication, just add that into, okay, here our value is in AX, right? We've multiplied the screen width, and it's all stored in AX. So now all we have to do is add our X value. Copy. Here, of course, it should be a memory location. Let's try that, shall we? Perfect. There. So this is polar coordinates. See, so now I could work with these values like position X, position Y. I could go outside the screen. I could go 100 pixels, 20 pixels outside the screen, and not lose, have it come back on the other side of the screen, basically. So and have it turn around and come back, and all the timing is correct and everything there. So yeah, I have converted everything to polar coordinates where X is down, right? Also known as pixel coordinates, and I remember when I was volunteering at Khan Academy, the question would come up every once in a while from, anybody that has already had experience with a 3D program. They've done a little 3D modeling, and now that Y is up. Or if you had a little basic trigonometry in high school, everybody knows Y is up. That's pretty straightforward, and then now it's like, why is Y down? And to make a long story short, it's because CRT monitors refresh the screen from the top left-hand corner down. They start up here, they go to the right, all the way down to here, right? So we're talking in pixel coordinates. Whereas before that, early computers actually did start in the center of the screen, and they used, instead of a monitor, they used something similar to an oscilloscope. Right, and it communicated in Cartesian coordinates, it's called, where you start from 0, 0 at the center. Here we're using 0, 0 would be the top left-hand corner of the screen, right? So then Cartesian coordinates would be when you put 0 in the center of the screen, and now it resembles your modeling program and everything. And so I do recall 5 or 10% of the people had a difficult time wrapping their heads around pixel coordinates or polar coordinates, and so, yeah, the next tutorial I'll go ahead and quickly cover how to convert this to Cartesian coordinates, for people that prefer to work that way as well.